Yeah, work. It's actually work. It turned on. Is a
So we got super far. By the way, you do have another option. I found that like yesterday, what I kept doing was make both graphs and then draw the line. There's not a law that says that you can't make the y equals x line first. So like if you wanted to build your line of reflection, this is this file is just like I left it yesterday. So I've done nothing except what we did yesterday. So if you wanted to draw your y equals x line, you could do that right now. And then it's kind of fun, that may not be the right word, gratifying perhaps, to watch as your points appear where they should. So we'll do a quick pauser. Do I need a pause or are we good?
no.
We good? You know what? I'm looking at that purple table and I feel like it's a tad incomplete. I feel like it should have maybe one more on it. Does anyone see the missing one? Yes, good. So I believe if I were to put in an input of 12, then I can backtrack my way around here. So if I input 12, oh God, sorry, I got away with it on the one. There you go, big guy. 12. So if you put 12 up in the green egg, 12 plus 4 is 16. What's log base 2 of 16? 4 is correct, and 4 plus 2 is 6. So having said that, let's go graph us some purple points. So the point -2, 3 is at left 2 up 3. And it's fun to look across the line and you can kind of wave hello to the homie over there. So like this guy and this guy, kind of where I'm moving my pen, those are homie points, right? That's kind of cool. And then -3, 2, he's got his homie across the way right here. And then 0, 4 is up here. And his homie is 4, 0 over here. 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. His homie is like they're really, really close neighbors here. Yeah, yeah. And then 12, 6 is way off over here. So this is 6, and then it's probably like 11, 12. I'm going to just kind of guesstimate over here. I still will maintain that the hardest part of this is the artwork. So what you have to understand is that each of these graphs has an asymptote. It's been a while since, I've really gone into detail about asymptotic behavior, but you can see, we already talked yesterday, you can see the red plane coming in for a landing. Tell me about the asymptote of the logarithmic graph. Where is it? I agree with Zane, it's vertical. And where would it be? Can you see it? It's definitely at -4, right?
Yeah.
And so, it's interesting that I don't know, you can kind of pick them out for different reasons. I don't know if that's the right way to say that, but like normally 2 to the x minus 2 would have an asymptote at 0, but because of the -4, it bumps his horizontal asymptote down 4. And then the purple guy has an asymptote right where it should. And we'll talk more about this, but wherever the argument of the log would equal 0 is where you're going to find an asymptote. So I am going to draw another asymptote in here, right here, just so that we all can have eyes on them. So that is him. And then we're ready to make a graph. So there's your two asymptotes and there's your two curves. And you can see clearly that they're inverses. Since I have a little bit more time today, I'm going to go ahead and give this a shot. So there's asymptotic behavior over here. And then it's going to curve across like this. And it's going to head over like such. B plus on that one. And then the red graph is going to behave the same way. His asymptotic behavior is down here along this bottom line. And it really does look like it's flat. I sometimes just chicken out and I don't even go very far out, but it's hard to hold the line there. Might be a little easier for you guys with a pencil and paper than on this board, but it's not simple. And so that's hey, so that's artistically what we're going for, is to get the sort of visual appearance. And like I said yesterday, we want to kind of see those lines like snaking or kind of like meandering around the inverse line. And that's kind of the goal, what we're going for in this lesson. So the goal of the lesson is, can I find the inverse of a function? That's an old lesson. Can I make a table of values for both the graph and its inverse, or the function and its inverse? And then can I graph them to verify that, yeah, those look like inverses to me? That's where we're at right now. And I do have to get in the way of this and say something. What I don't want you to do, and it's hard for me to tell you this because like a smart person would be like, why can't I do that? And these are hard. It's like the first day you meet a ninth grader telling them that they have to show their work on X plus 5 = 8. That's a tough sell, but it's what I do. And I have to tell you, if you haven't figured this out already, what do you notice about that point that I just circled? 2, -3. Tell me about it.
You just swap them around.
You can just swap the numbers and it's going to appear in the other table. I didn't want you to find that out on your own and think that you had some sort of like breakthrough and that, oh, I found a shortcut. The reason that's kind of a ghetto shortcut is because I don't want you just forcing the issue to make it look the way you think it should look. I want to make sure that the points that you're getting in the purple table are legitimately being produced by this. So don't just do one table and then ghetto switch all the numbers. I mean, I'm asking please, because that's just it's not sensible. I could wind up having a completely wrong graph. And then if I'm ghetto swapping, then I'm going to have not only a bad graph, but a bad graph of my inverse as well, because I'm basing it all off of half-hearted work. So please be legit about the process and do it just the way we did it in our notes. Got her? It is a good way to check, however. Like if you do it legit and then you're able to look at both tables and eyeball and see, like in this table, you can see that, do you see how they all match? How they all have an inverse pair like a match? That's okay to check after the fact, but to just swap them, I think, is pretty cheesy and risky. So, you have any questions for me? All right, I'll leave this paused. I'm going to hand out your assignment. You're going to work on it, and that's it. That's it for the day. Today, the whole day, 37, 8, 38, 38 minutes left. Get her done. You're rocking over there. Some peanut butter M&Ms. Yeah, boy. Nice work. Way to save me some. Thank you.
I do have a back.
Appreciate you.